Hi students, this is the first in a series of videos for the topic of further functions. It's for the International Baccalaureate course Analysis and Approaches. In this first lesson, we're going to look at odd and even functions. So let's start with even functions. A function is even if f of negative x is equal to f of x for all x in the domain of f. And the graph will be symmetrical about the y-axis. So let's show that f of x is equal to 1 minus x squared is an even function. All we have to do is substitute in negative x for x. And negative x all squared, of course, is x squared. So f of negative x is equal to f of x. We've shown that f of x is an even function. If we have a look at the graph, you can see that the function is symmetrical about the y-axis. The function is odd if f of negative x is equal to negative f of x for all x in the domain of f. The graph of f has point symmetry about the origin. And remember, point symmetry means that if the graph is rotated through 180 degrees, it will be identical to the original graph. So let's show that f of x equals x multiplied by x squared plus 1 is an odd function. Again, we're going to substitute negative x for x. And again, negative x all squared is x squared. But can you see how that is the negative of this? So because we've shown that f of negative x is equal to negative f of x, we've proven that f of x is an odd function. Here's the graph. You can see the point symmetry about the origin. But of course, functions can be neither even nor odd. Let's show that f of x equals x minus 1 is neither even nor odd. Again, we're going to substitute in negative x. This time we can see that that is not equal to f of x, so it is not even. And when I factorize this negative out, I don't get the negative of this function, so it's not odd either. And graphically, it is not symmetrical about the y-axis, and it doesn't have point symmetry about the origin. So let's have a think about what the rule is here. By inspection, decide if the following functions are odd, even, or neither. Now this first one, we have got power of 4, power of 2, and a power of 0. This one is going to be even because it contains only even powers. Here we have a power of 3 and a power of negative 1. This one will be odd because it contains only odd powers. Here we have a power of 2, a power of 1, and a power of 0. We have a mixture, so this one is going to be neither. Now, just saying that you have only odd powers or only even powers isn't going to work with a quotient. Let's have a look at this one. This one's actually odd. Can you tell why? We have an odd function on the top and an even function on the bottom. And when we substitute in negative x, the top term will become negative. So this is an odd function. Which leads us nicely into combining functions. What can be said about the sum of two even functions? So we're going to let h of x equal f of x plus g of x, and both f of x and g of x are even functions. So let's substitute in negative x and see what we get. Because these are both even, this is equal to f of x and this is equal to g of x. And so that's equal to h of x. So the sum of two even functions is even. And here's some other combinations. What can be said about the sum of two odd functions, the difference of two even functions, the product of an even and an odd function, the quotient of an even and an odd function. I'm not going to work through those, but I encourage you to. Now, a very famous even function is cos x, and a very famous odd function is sin x. And you can see that from the graph. Here's cos x it has line symmetry in the y-axis, and here is sin x, and it has point symmetry about the origin. And these facts, the fact that cos is even and sine is odd, can be very useful with complex number questions. What about tan x? Is it even, odd, or neither? Best way to do this question is graphically. We can see it's not even because it's not symmetrical about the y-axis. But it is odd. It has point symmetry. If I rotated that graph 180 degrees, I'd end up with the original graph. So tan x is an odd function. Okay, that's it. Our next lesson is going to be on how to graph the square of a function.